Hello everyone, I welcome you all to this lecture. In previous lecture, we had discussed security at the network layer. In this lecture, we are going to discuss security at the transport layer, which is the fifth chapter of the third module. In this lecture, we are going to discuss transport layer security in terms of secure socket layer, in short SSL. SSL is a protocol that is developed by Netscape in the year 1994 and which is emerged as the principal means of securing communication between an internet client such as user browser and that of server. This SSL was standardized by Internet Engineering Task Force in the year 1999 and also called as Transport Layer Security, in short TLS. This SSL protocol, which is placed or sandwiched in between that of the TCP and an application layer protocol. So here one major protocol under transport layer we know is transport control protocol, that is TCP. Why? Because SSL runs only over TCP. So the SSL which is placed in between the TCP and that of an application layer. This protocol is an application protocol independent. There are several protocols such as HTTP, Hypertext Transfer Protocol, File Transfer Protocol, Simple Mail Transfer Protocol, Internet Message Access Protocol, and Post Office Protocol, so on, can all be running over SSL. To have the security, then these application layer protocols are able to run over SSL. Now, application layer protocols which are secured by secure socket layer are usually suffixed by S and run on different port numbers. For example, HTTP runs on a well-known port called 80, but HTTPS, that is HTTP with security with respect to SSL protocol, which runs on the port number 443. Similarly, FTP runs on a well-known port number 21, but file transfer protocol with security with SSL enable runs on port numbered 990. So this is what the secure socket layer, its little introduction. Now let us see the SSL, which is comprised of the two main protocols, namely the handshake protocol and the record layer protocol. This diagram shows the SSL on the protocol stack. As I told, the SSL which is placed in between that of the application, which is having several protocols like FTP, HTTP, so on, and that of the TCP, transport layer protocol it is, and dot 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 shows okay the several next layers. Now this SSL is comprised of two protocols, handshake protocol and the record layer protocol. So this is the layer showing the SSL handshake, and the below layer to it is SSL record layer protocol. So let us discuss these protocols one by one. The SSL handshake protocol is used to negotiate the set of algorithms to be used for securing the communication link. So handshake protocol, which is used to negotiate the set of algorithms. So definitely to send a information or a message, definitely we required a set of algorithm, the cryptographic algorithms, and there we discussed security association must be negotiated between the parties who wants to securely communicate. In the previous lecture video we seen security association, exchanging of the information such as the lifetime, the validity period, anti-reply window, or the cryptographic parameters if any, along with the sequence numbers used with the packets, etc. These kind of things or knowledge is brought into the parties which are involved in the communication. So that is what negotiating the set of algorithms to be used for securing the communication link. So handshake procedure is like a introduction. So now then the server authentication in SSL is mandatory and is performed as a part of handshake. With the handshake, what we can say is, with respect to SSL, the server authentication is must or it is mandatory. Okay, so the handshake protocol is also responsible for deriving the keys for encryption and MAC computation, etc. So here we already aware that there we are using the long-term secrets, short-term secrets. Long-term secrets, they are used for the longer duration of the session. Short-term keys may be derived from the longer secret keys. So after having some functions applied over several parameters to derive the some more secrets, so they may be used for the shorter span of time. So they are the shorter term keys. Now in that way, the handshake protocol is responsible for deriving the keys for using encryption and later words the message authentication code computation. The actual job of providing a message authentication, the integrity checking and encryption is performed by the SSL record layer protocol. Very importantly, the handshake procedure is the first thing, whereas the nextly we must use the record layer protocol, which is helping us to have the message authentication, integrity checking and encryption. So the SSL record layer is responsible for all these activities. Now the record layer protocol, it sits just below the handshake protocol and protects the each of the messages exchanged by the two communicating parties. Yeah, shown in this diagram, the record layer protocol is must be sitting below the SSL handshake protocol. Now the record layer protocol also detects replayed, reordered and duplicate packets. These are the very essential services along with the security, the major security concern. So the record layer protocol also responsible for finding out replayed, reordered and duplicate packets. So let us see the steps which are involved in the handshake process or the procedure or the protocol you can call. Now there are the steps are as follows. The client first initiates a handshake with the server to either start a new session or resume an existing session, or which also able to establish a new connection within an existing session. So there are the three possibilities. The main steps in the SSL handshake for establishing a new session is as follows. The first one is there must be an agreement on a common cipher suit to be used in the new session. So here the cipher suit, cipher means the procedure how we are going to have the encrypted messages. So cipher suit means the group. So here we are going to have the sharing of and set of algorithms which can be used for encrypting the messages. So that can be done by the client and the server. So that is what the agreement on a common cipher suit. The knowledge should be brought into other parties to which we are having the communication to have a new session. Now later the server is going to send a certificate to the client. Now the client needs to receive that certificate and validate the server certification by the client. So we already aware that the digital certificate or the certificates, so where we are having the information about the signature algorithm, the certification authority, the validity period, the issue number, the certificate number, version, etc. So these kind of information are put in the server certificate. Now the clients needs to verify or and validate the server certificate. Now the third step is communication of a pre-master secret and competition of the derived secrets. Now client is able to have one pre-master secret and computation of derived secrets. The client must be also able to use this pre-master secret and which could able to send it with its encrypted manner to the server. So the client must be communicating a pre-master secret with its encrypted version to the server and also the computation of the derived secrets. And next fourth step is integrity verification of handshake messages and server authentication. The now the client must ensures the server authentication, also the integrity verification that the messages are not going to be altered. So these steps are realized by the sequence of messages shown in the figure named SSL handshake. So here I would like to discuss this one in terms of the four steps. So there are set of messages can be exchanged here. Okay, so I would like to tell, okay, the first step is the one where two messages are communicated in the first step are client hello and the server hello. So now, okay, so here this step, so where uh, there are the following decisions are taken here. Okay, so either by having the client hello, if the first step is over, then the decision can be done in such a way that should a new session to be established or should an existing one be reused. For new session, the id field in the client hello message is 0. else the field is set to the ID of the session to be reused. The session ID field in the server hello message is the ID of the new session to be established or the ID of an existing session. So the algorithm to be used in computing the MAC for message integrity, including the algorithms such as message digest 5, MD5 and SHA1 secure hash algorithm with version 1. So the key exchange method used for communicating the pre-master secret. In addition to agreeing on a cipher suit, both sides chooses a exchange of two 32-byte nonces RA and RB in this step. So what happens is in the first step, so there they are going to say that they wish to communicate to the other parties by saying a hello, but along with that they needs to have a session ID to be exchanged. Along with that, okay, it depends on again whether new section or the existing session. And now along with that, the key exchange method used for communicating the pre-master secret. Now client is able to have a pre-master secret that can be sent, okay, as a cipher suit to the server. Now, in addition to this cipher suit, both sides choose and exchange 32-bit nonces. So there, I would like to say it in the form of R suffix A and R suffix B. So these are the two random integers selected by A and B. A and B you can consider as client and server respectively. So they are of the 32 bytes. Now, so it is what the first step, okay, the client hello and the server hello. And now moving to the second step, the server communicates its certificate to the client. Here you can see this is the second step I can consider, where server is sending its certificate to the client. Now on receipt of the certificate, the client checks the owner name or the URL and validity period, the other details. It also verifies the signature of the certification authority on the certificate. Successful verification of these fields does not guarantee the authenticity of the sender. So now the one thing is the verifying all the details, but successful verification of these fields does not guarantee the entire authenticity of the sender. But okay, so authentication of the server only occurs at the end of the step 4. So now the along with the certificate we have to move on to the step 3 and step 4. So let us have the step 3, in which the client chooses a pre-master secret, which is a 48-byte random number. So there must be a master secret key will be chosen by the client, which is of the 48-byte random number. Then the pre-master secret is encrypted with the server's public key. The client uses the server's public key to encrypt that 48-byte random number and send to the server in the client key exchange message. So here in the step 3, I am able to show here there will be a message from client to the server, client key exchange. Here the client will be encrypting a 48-byte random pre-master secret with its encrypted manner onto the server. Now thereafter both client and server computing the master secret. Okay, this is like a HMSC style function F. So where the master secret is going to have the function applied over the parameters such as the pre-master secret key selected by the client and the nonces which are exchanged in the step 1, those are in the form of RA and RB along with some integer constants. So now that is how, okay, so the client is going to exchange its key with the server. So now there are the 6 secrets we are going to derive. So in the form of the following: initialization vector for encrypting a message from client to the server, initialization vector for encrypting the message from server onto the client, secret key for encrypting messages from client to the server, secret key for encrypting messages from server onto client, and next secret for computing keyed hash on messages from client onto server, and secret key for computing keyed hash on message from server to client. So in both the way, client to server, server onto the client. So these kind of derived secrets we need to have. So again, these derived secrets are computed only after applying the function f over the master secret and the again two nonces, that is RA and RB along with the integer constants. So this is what covered with the step 3. Now you cannot consider here the step 3 is only client key exchange. So again what happens, so these together 5 messages exchange which is covering both the step 3 and step 4. So let us see what happens in the step 4. So this fourth step involves the exchange of the 2 messages in each direction. So now you can see there So there will be a change cipher specification and finished message, and now change cipher specification from server down to the client, and finished message from server to client. You can see this is like a 4-step. Now the party that sends the message signals that from now on the cipher suit and the keys computed will be used. The second message in the step is the finished message. So change cipher specification, which indicates they agreed upon use of the keys or the previous knowledge what they exchanged. They agreed upon using or reusing such an information. Now after that, okay, so they are accepted. Okay, they finished. Okay, their conversation means they have agreed, and the finished message indicating that they agreed, they completely agreed upon the messages what they previously exchanged. Maybe a session id, maybe a master secret key, the encrypted value of it, okay, the random nonces, and the certificate also which been sent by the server onto the client. And there we are going to have the derived secret based on the master secret. So these kind of knowledge will be now all aware to both the parties, and now they agreed upon all these things. So that is what the thing with the 4-step. Now once if it is a case, then both the parties they can start communicating by using the ssl record layer protocol, okay, for the further processing of packets. Now uh, this is what the ssl handshake process. Here there are the three key design ideas with respect to the ssl handshake, which are key exchange methods, server authentication, and that of the sessions and the connections. So for more discussion you can refer the prescribed textbook, so how they can be acting as key design ideas. So let us move on to the next layer of the ssl protocol, that is ssl record layer. Now this SSL record layer protocol is used to securely transmit data using the negotiated cipher suit and the keys derived during the SSL handshake. Now the main tasks of a record layer protocol are computation of a per message authentication code and encryption. If the data to be transmitted is very large, it performs the fragmentation. Each fragment is of 16 KB or less. So now, okay, I would like to have the explanation along with the diagram. So when a connection is established, both sides initialize a sequence counter to 0. Every packet must be identified by their sequence number. Initially, the sequence counter is set to 0. This counter is going to be incremented for each and every packet if it's sent. Then the sequence number itself is not sent. However, it is used in the computation of the MAC at the sender side and its verification at the receiver side. So let us have, suppose if the application data is received by the particular layer, that is at the transport layer, then it can be viewed in the form of the fragment. Why? Because if the message is too long, then we should have the fragmentation. Why? Because each fragment is of only 16 KB or less. If it is greater, then you must perform the fragmentation. If the fragment is received from the upper layer, then the next step is the MAC is computed on the concatenation of the 64-bit sequence number and the compressed fragment. If you are using the compression, then definitely, okay, so this every fragment is going to be identified by the 64-bit sequence number. Then along with this, the MAC is going to be computed on the concatenation of the 64-bit sequence number, which is used to indicate this fragment, and the compressed fragment itself. So the MAC is going to be added at the end. Now the next step after computing the MAC is encryption. If the combined size of the data fragment and the MAC is not a multiple of block size, then a padding approach is used. Here I have not added anything to indicate the padding, but if the fragment size including the MAC, which is not a multiple of block size, then definitely padding is required to make it a multiple of block size. Then the data fragment MAC and pad are all encrypted, prepended with the header, and passed on to the TCP layer for further processing. So once this encryption is taken place, including the fragment MAC and padding if it is necessary, then okay, while moving to the next layer, what will happen is in the next, as a next step, So this encrypted version can be now prepended with the SSL record layer header. So what happens here is this SSL record layer header consisting of three fields, namely a content type field, next one version number field, and finally length field. So the content type field, which is a 1 byte field, which is used to identify the higher layer protocol used to process the fragment, and next field is the version number field, which is 2 byte and which is used to specify the version number, and finally the SSL record layer header consisting third field as length field, which indicates the fragment size in terms of bytes. So these are the three fields which can be constructing a SSL record layer header that can be added along with the encrypted fragment including MAC or padding if any, then can be forwarded to the next layer. As it is, if it is at the sender side, then next layer is going to receive this fragment with its the header information of the record layer, etc., moved on to the next layer. So this is what the functions of the SSL record layer protocol as well as the handshake protocol, what we discussed in the previous slide. Now the last concept in the fifth chapter is OpenSSL. So OpenSSL is an open source software that implements the secure socket layer or transport layer security protocol. It is comprised of a number of libraries that implement various cryptographic algorithms. It provides extensive support for communicating and validating digital certificates. OpenSSL is based on SSLi library developed by Eric A. Young and Tim J. Hudson. OpenSSL enhances the productivity of application developers by providing a rich set of and application programming interfaces that handle diverse aspects of SSL-enabled communication, from connection setup and tear down to certificate storage, management, and verification. The developers can rely on the OpenSSL APIs to implement the required security. So with this, I can conclude chapter 5, that is security at the transport layer, which also covers module 3. Thank you.